So for today's Do Now, we're solving a system of equations. I'm going to take a screenshot of this so I can annotate on it. Okay, so it says solve the system of equations. Now you can solve a system of equations lots of ways. You can do elimination, you can do graphing, or you can do substitution. Now, most of the time, elimination is going to be your best bet. So basically, you're looking at these two formulas here, these two equations. And you're seeing x plus 2y equals 3 and 2x minus y equals 1. So when you look at these two equations, you want to look at the x values. They won't subtract. If you subtract them, you wouldn't get 0. And then you want to look at the y values and see if you subtract the y values if you get 0. And in this case, you wouldn't get 0 either. So I can take the top equation or the bottom equation and multiply it by a number. In this case, I'm going to multiply by the number 2. I'm going to take this bottom equation and I'm going to multiply the whole thing by 2. So what happens when you multiply this whole thing by 2, you get 4x minus 2y equals 2. Right, you got to distribute to all three. So now we're going to write the bottom equation underneath it. The bottom equation was 1x plus 2y equals 3. Okay, let's go ahead and add these together. Well, what's 4x plus x? That's going to be 5x. What's negative 2y plus 2y? That's 0, so we're not going to write it. Equals, and then what's 3 plus 2? 5. Now we just solve. Divide both sides by 5, and x equals 1. So we know x is 1. Well, what's y going to be when x is 1? So I'm going to pick any equation. I'm going to pick this top equation, and I'm going to plug in 1 for x. So instead of writing x plus 2y equals 3, I'm going to write 1 plus 2y equals 3. So you can use your common sense and solve this in your head, or you can go ahead and write out the steps. Subtract 1 on both sides. You get 2y equals 2. Divide by 2, and y equals 1. So when x is 1, y is 1. So my answer looks like this. This is a point on a graph, 1, 1. So if I plug these numbers back in, I would get 3 on the first equation. If I plugged 1 and 1 back in, I'll get 1 on the second equation. We've already gone over midpoint, segment, bisector, and perpendicular bisector, so you should be good there. Next, what I'm expecting you guys to do is go ahead and drag each one of these into the correct spot. See if you can figure out what a point, a line segment, a ray, opposite rays, and a plane look like. Here's a finished product, so check your answers. So let's talk about the difference between spherical geometry and Euclidean geometry. So Euclidean geometry is the type of geometry that we study in class. It was made by this old guy named Euclid. In Euclidean geometry, it's a study of flat space. And in Euclidean geometry, we said that two lines always intersect at a point. A point is the location where those two lines intersect. A line is created by 2 points. Through any 2 points, that will always form one line. And then a plane in Euclidean geometry is a flat surface. But in spherical geometry, that's a study of a sphere. Where is your plane on this in spherical geometry? Your plane is actually the entire surface of the sphere. Is that surface flat? It is not. Okay, imagine you wanted to draw a line on this sphere. So take your pen or marker, and I want to draw a line. I'm going to start here. And draw a line. Well, what shape does that line? It's actually not a line at all. It's actually a circle. The line keeps going on top of itself. So in Euclidean geometry, a line is actually a circle. We call this the great circle. Look at that circle. Isn't it great? Okay. Now imagine I have my first line right here, and I want to draw another line right here. How many times do these two lines intersect each other? Hopefully you can see they intersect twice. So in spherical geometry, lines don't intersect once, lines actually intersect twice. That's because you have two circles. So they intersect at 2 points. We're going to continue to talk about the differences between spherical and Euclidean geometry throughout the school year, but Euclidean geometry is the type of geometry that we'll mainly focus on this school year. When you are finished, I'll expect you guys to work on your Desmos card sort activity. I will insert the link for you to have. You can also find it on Google Classroom with instructions. After you're done with the Desmos card sort activity, please let me know. What did you learn? Do you have any questions? Is there anything that came up that you still don't understand? That way I can cover these in class. And then last but not least, your exit ticket. Complete your exit ticket. Compare and contrast these words: line, line segment, and ray.